Hi, so today we're going to talk about building a hello program in C++ on Linux, as you can see right here. So before we can get started though, we need to add some packages to our system. So if we click on terminal, since there's not a terminal down here, we can do a new terminal. And we can use sudo apt install. Again, this is on Linux, so sudo apt install build dash. If you hit tab, it'll autocomplete for you. If it doesn't quite know what you're looking for, if you hit tab twice, it'll give you a list of all the options. Then we'll do CMake, Ninja, build, G++, and GDB. So Build Essential will give us all the things to build on our system. CMake is a tool that's very handy. You'll see that soon. Ninja does a bunch of magic for us behind the scenes. G++ actually converts our source code into something that can run, and GDB allows us to debug. I have all these installed, and hopefully by now you do as well. I will be using Visual Studio Code for all these examples. If you would like to follow along, I welcome you to do that. If you are on Windows and for some reason you're watching this video, even though it clearly says this for Linux, I would recommend using the Windows subsystem for Linux. It allows you to basically run a virtual machine of Linux inside of a window on Windows for you. And if you do that, I would recommend this WSL extension. Now, other extensions that are handy is the C++ extension pack from Microsoft. That'll automatically install these guys. And then CMake allows you to highlight CMake text lists, CMake list text, so that you can actually read it and it's not just all white like this is. CMake tools will give us a handy toolbar at the bottom that will soon appear for us. And I also like using Control-D to duplicate my lines, and I like commenting and uncommenting using hotkeys. So I will be using the Visual Studio key mapping since I am familiar with that. That is purely optional. You do not need that if you are not familiar with those key mappings. All right, so let's get to it. We're going to add a main.cpp file, and we're going to include, with a pound sign, there we go, IO stream. By default, C++ comes with basically nothing. There's a few keywords in there like int and return, for, and a bunch of other things that you probably don't know about yet. Otherwise, you wouldn't be watching this video. But a lot of things that you don't need all the time are not included by default. So IO stream is for input-output stream. It allows us to display things like these words on the console here or in the terminal. If you're making a windowed-based program, you probably don't care at all about showing things in the console. So therefore, it is not included by default. Or if you have no output, like your program just performs a task for you, maybe it makes a file or something, but you don't actually want to show it on the screen, then you would not necessarily need to include some of these things. So by default, you don't get absolutely everything under the sun. You include the things that you need, which keeps your files small and hopefully your code less confusing. After that, we have int main. Now, int is an integer type, which holds negative and positive integers, a large quantity of them. We won't get into the limitations. There's always a limitation, but for any number that you want, it probably will cover it, and you need it. So there you go. Main is the starting point of the program. Now you can use this little / to indicate comments. So we're going to say input output streams, which allows us to stream data in and out. This is the main start function of our program. There's another way of writing this where you can include things from command line parameters. We won't get into that now. We're going to try to keep this as simple as possible. Not sure why that Expecting, oh. So, yes, any function that you use will be wrapped in these curly braces. It basically means begin doing stuff. You're done doing stuff. We'll leave it at there for now. After that, we're going to do std for standard, cout for outputting to the screen, these two less than signs, which basically mean take whatever we're going to take and shove it into that display object. We're going to say hello world. And after that, we need a semicolon. Semicolon, sort of like a period at the end of the sentence. It means I am done doing things. If you don't include it, it will not be happy with you. You can see this little squiggly appeared. It says it's expecting a semicolon. So we need to include that. Now, you might be wondering, what is with the standard and cout? Well, a good way to think about it is standard's what's called a namespace. A namespace is sort of like a folder. If you look down here, I'm starting in my home directory with the little tilde, and then I have a slash. I have my desktop directory or folder, slash, there's a folder in there called C++, slash, and then there's a hello world folder. So inside of a folder, you can hold more folders, and you can also hold files. A namespace is kind of like that. It can hold more namespaces, which is basically like a folder, and it can hold our classes. It can hold our functions. It can hold variables at a very global level. It can hold different code for you. And instead of using a slash, or on Windows a backslash, we use : to indicate that we're looking inside of this folder. All right. After that, we need to return 0. So int means it's expecting a return, and we're returning the number 0, which means no errors occurred. You'll remember if you used old operating systems like Windows 95 or 3.1 or DOS, things like that, that if something went wrong, it might say error, and then it would throw out a number at you, and then you would, well, that might have been before the internet, so you had to go to a book and look inside the book and look at the error code, and it would say this error means that this thing happened. That's basically what we're doing here. 0 means nothing went wrong. All right, so what we can do now is we can do G++. We can type main.cpp, and you'll notice that an a.out has appeared inside of our folder. If you want to use the command line to see that, you could do ls for list, and there's an a.out. So let's run it. Period slash means run what I want you to. We'll do a, and we can hit tab. And it says hello world. Also, apparently there's no new line character, so let's add one of those. We're going to add another set of less than signs here, which basically means concatenate, and we're going to put in an end line. Let's run this again. Oh, also, if you make changes, a little dot will appear here. That means you need to save. And if you, once I do Control S, the little dot goes away. So I'm not going under File and clicking Save each time. We will hit the up arrow a couple times until it says what we want it to do. We're going to run that again, and if we hit it a couple more times, it's basically, it returns our history for us. We'll run it again, and now we're on a new line. So there we go. But there's one more thing. We want to incorporate CMake, and I will show you why. We're going to add a new file. It's called CMake lists with an S on the end. Don't ask me why, but it does. And I believe it's case sensitive as well. So .txt. We're going to type in CMake minimum required, which is the minimum version required. Now you might be wondering, how did it know to pop all that up? Well, it recognized CMake lists as the name, and one of those extensions knows that to turn this blue when we are in CMake lists, and it automatically gives us these auto completion things. We're going to type in project, and we will call it hello. This will be the name of our project and actually the name of our executable. And then we're going to add an executable. And I could type hello here again, but I'm actually going to type in project name, which will always be the same as whatever our project is named. After that, we put in main.cpp, which is the file that we want to compile. And now we should be set. If we hit F1, or you can do Control-Shift-P, it will pop up this list. And what we want to run is CMake configure. It will do all of this stuff for us automatically. And if this is your first time running it, it might not pick a compiler by default, so that it'll give you a list like this and you can scan and different things. We're going to be using GCC. We also have the ability to do debug, which is a nice feature to have. What this allows us to do is step through our code. We'll illustrate that soon. And we can also just do the release version of our code, which is designed for speed, but it also will be smaller because it won't include all of our debug information. So let's click build, and you can see that it built, it's linked everything, and we got an exit code of 0, which means everything succeeded, as we recently talked about. So if you click over on this left-hand side, you can turn on and off a breakpoint. A breakpoint allows us to stop the execution of our code while it's running and actually go through it line by line to try to find problems. So let's illustrate that by clicking on this little bug down here for debugging. You can see we got a nice little toolbar up here. Continue means take us all the way to the end and kicks us out right away. If we click that debug again, we can also step through our code and it'll go through line by line. Very handy. You'll notice we're on terminal. It might start on debug console. You see all this orange and blue stuff and this doesn't look like what you want. Switch over to terminal or maybe output. And I'll just continue, or we can actually hit stop. I won't talk about these other ones. Only caveat is, well, I will talk about restart. Restart allows you to rerun the program again. However, it will not rebuild your program. So if you make changes and save it and click restart, you actually that won't work for you the way that you're hoping it will. You'll need to actually click build again or click the little bug again. And we'll click stop. We're done looking at this. Now to actually show what stepping through lines of code looks like, let's change it to hello and world on separate lines and click the little bug again. So it automatically, it stopped here because my breakpoint was here. So it already ran the hello line of code, which we can see. Now if I want to run the world line of code, I can click step over or hit F10, and now it went to the next one. So that's really basics on how debugging works. So we have displayed hello world on the screen. You have all the packages and extensions you need, and we have a working proof of concept. Talked about namespaces. We talked about the various things in the namespaces. We have semicolons at the end, curly braces to wrap things up, and what include is doing for us. So I look forward to seeing you in the next video.